Hello, mathematicians. Today we're going to talk about velocity and how to find out when a particle is moving to the left, to the right, and when it is stopped or at rest. So if it's moving to the right, that means the position is increasing. We're getting farther and farther away from our initial point. If it's moving to the left, the position is decreasing. Again, we're getting farther and farther to the left. So for example, if this was our position graph and we started at 0, moving to the right, we're getting farther and farther away from that 0. And if we move to the left, our position is decreasing, moving away. So our velocity is positive if we move to the right and negative if we're moving to the left. Now, most of the time they talk about right and left. Sometimes they'll talk about forward and backwards. At rest is when the velocity is 0, meaning it's not moving. The speed is 0. Or the position has a horizontal tangent line, which is the same thing. Now, one thing that's important to note, this is an instantaneous velocity of 0. So sometimes it can be over time, sometimes it can be for like a split second that the velocity is 0. Let's do an example with an equation. A particle moves horizontally, modeled by x of t equals t squared minus 4t plus 3, where x is in feet and t is in seconds for t greater than 0. When is the particle at rest? So when I see at rest, that is telling me that the velocity must be 0. So to find velocity, we first need to take the derivative of the position. So x prime of t is what we need to find. So the derivative is 2t minus 4. Remember that 3 goes to 0. Now that we know this is our velocity, we set this equal to 0 to find when this velocity is 0 when it is at rest. Do a quick solve. 2t equals 4. Divide 2, we get t equals 2. Now do a quick check. Is this number within our region? Yes, 2 is greater than 0, so that's a good number. And we always have to justify. So we're going to say the particle is at rest at t equals 2, include the units, seconds, because the velocity or x prime of t is 0. So now we need to find when it's moving to the right. If it's moving to the right, that means our velocity is positive. So we can put in a sign chart here. Now I'm going to start at 0 because that's my region. And then my point is at 2. That's where it's 0. Now I have to check my velocity at different test points. So let's a point between 0 and 2, 1. So if I plug in 1 into my velocity, I get 2 minus 4 is negative 2. So here it's negative 2. What's a point greater than 2? 3. 2 times 3 minus 4, 6 minus 4, that's going to give me a positive number. So when is it moving to the right? When velocity is positive, so that is t greater than 2. So we'll write it as a sentence. The particle moves to the right for t greater than 2 seconds because v of t equals x prime of t is greater than 0. And to find when it's to the left, well, we're just going to use this negative part. So we can write the particle moves to the left over the interval (0 to 2 seconds) because v of t equal to x prime of t is less than 0. Now, this is with equations. Let's take a look with a table. So here we have this table, and it is modeling a test plane that flies in a straight line with positive velocity v of t in miles per minute at time t minutes, where v is a differentiable function of t. Selected values of v of t for t between 0 and 40 are shown in the table above. Does the data represent velocity values of the plane moving away from its point of origin or returning to its point of origin? Give a reason for your answer. So we want to say, is it moving away or is it returning? So moving away is the same thing as going farther from its origin. So that means the velocity must be positive. If it's returning, then the velocity must be negative. Well, if we look in our table, this is our velocity. And all these values are positive. Now, they go up and down, but no matter which one you look at, it's going in the positive direction. So it's speeding up and slowing down, but the velocity stays positive, so it is always moving away from the source. So we're going to say the plane moves away from its point of origin because v of t is positive. So let's do an example with a graph. Now we have to be careful with graphs because they sometimes give us different things. If they give us the graph of a position, we're going to have to make statements using position. If they give us the graph of velocity, we have to make statements using the velocity reasons. So this graph, they tell us, is the position. So if we want to find when the particle is moving to the right, we have to look, where is the position increasing? Increasing means going up, having a positive slope. So if I look here, the only spot where it has a positive slope is here. The slope is positive between 3 and 6. So t is between 3 and 6. Or you can write that in interval notation, 3 to 6 seconds. Because x of t is increasing. Now we can't say because v of t is positive because they don't give us v of t. If they give us x of t, we have to say x of t in our reasoning. So when is it moving to the left? It's moving to the left when the function is decreasing. Decreasing means going down. So here it's decreasing, and here it's decreasing, going down. The slope is negative. So we can say between 0 and 2, union 6 to 7, because x of t is decreasing. The final question asks us when the particle is at rest. Well, remember, at rest means the position has a horizontal tangent. It needs to be horizontal. So it is horizontal over here and over here. So between 2 to 3, union 7 to 9, because x of t is horizontal. Now let's treat this as if it is the graph of a velocity. So if this is the graph of velocity, we will need to use our velocity statements. To find when a particle is moving to the right, we need to see where the velocity is positive. The velocity is positive when it is above the x-axis. So here the velocity is positive, and here the velocity is positive, because it is above the x-axis. The y values here are positive. Our velocity values are positive. So between 0 to 1, union, maybe that's 5.1. 5.1 to 7. Because v of t is positive. Or you can say because v of t is above the x-axis. To find when it's moving to the left, we have to look at where the velocity is negative, where it is below the x-axis. So here, our velocity is negative. Anywhere below the x-axis. So we're going to say from 1 to 5.1, because v of t is negative. Or you can say v of t is below the x-axis. Finally, to find when the particle is at rest, we need v of t equal to 0. So when is v of t equal to 0? When it is on the x-axis. So on the x-axis, we're looking for our roots. And here, it's completely on the x-axis. So we have at t equals 1, t equals 5.1, and t between 7 and 9. Because v of t equals 0. So again, be very careful when you determine moving left to right and at rest if you are given the position or the velocity, because what you do and the answers are completely different depending on whether they give you position or velocity.